Every morning, you unlock your phone, check the weather, and navigate traffic, without realizing quantum computing already powers parts of this routine. These technologies rely on algorithms refined using quantum principles, speeding up everything from encryption to logistics. This isn't science fiction, it's happening now. In fact, IBM has already made quantum processors accessible to researchers and developers, pushing the boundaries of what's computationally possible. But what does that mean for you? How is quantum power shaping the world behind your screen? The truth is, quantum computing isn't just about solving impossible problems, it's reshaping the tools you use daily. From optimizing delivery routes to improving medical diagnostics, quantum influence is subtle but profound. This video will uncover how this unseen revolution is already at work, changing the way we live, one invisible calculation at a time. At the heart of quantum computing lies the qubit, a quantum bit that defies classical rules by leveraging superposition and entanglement. Unlike traditional bits, which exist in a state of 0 or 1, qubits can be both simultaneously, enabling quantum computers to process vast amounts of data in parallel. Researchers say this unique property allows quantum systems to solve complex problems exponentially faster than classical machines. IBM Quantum has led the charge in advancing both hardware and software, offering public access to quantum systems that once existed only in theory. Take, for instance, the 127-qubit Eagle processor launched in 2021, a milestone that demonstrated the feasibility of scaling quantum hardware. As quantum computing continues to evolve, it's not just about speed, it's about redefining what's computationally possible. This shift sets the stage for exploring how quantum power might shape industries from medicine to finance in the next scene. IBM's journey in quantum computing has been marked by groundbreaking achievements. In 2023, the company unveiled a 127-qubit processor, a major leap in scalability and performance. This milestone reflects years of progress in qubit stability and error correction, two of the biggest hurdles in quantum computing. Researchers at IBM have focused on improving the coherence time of qubits, allowing them to maintain their quantum state longer and perform more complex calculations. A recent report from the Journal of Supercomputing highlights how IBM's innovations in both hardware and software are setting new benchmarks for the industry. Consider the implications. With each additional qubit, the computational power of these systems grows exponentially. This isn't just theoretical. IBM Quantum has already provided access to these systems for academic and industrial research. As the technology matures, the ripple effects will touch fields from cryptography to drug discovery. The road ahead is clear, and the next scene explores how quantum computing is already reshaping scientific research. In the fast-paced world of logistics, quantum computing is quietly reshaping the game. Take DHL, which has experimented with quantum algorithms to optimize delivery routes, slashing fuel consumption and delivery times by up to 20% in pilot programs. These algorithms process countless route permutations in seconds, something classical systems struggle to match. A recent report from IBM highlights how their quantum systems are now capable of solving complex optimization problems that once took days, now done in minutes. Picture this: a fleet of delivery trucks navigating a city with real-time traffic updates, each reroute calculated to minimize delays and emissions. Researchers say this isn't just theoretical. Early implementations are already showing measurable environmental and economic gains. As quantum hardware improves, these benefits will only scale. This brings us to the next frontier: how quantum computing is transforming healthcare diagnostics. UPS, a global leader in logistics, has quietly harnessed the power of quantum-inspired algorithms to streamline its delivery routes. By applying principles derived from quantum computing, the company optimized its network, reducing fuel use and delivery times. This initiative is part of a broader trend where quantum-inspired solutions are making real-world impacts. IBM Quantum has been at the forefront of advancing quantum hardware and software, offering tools that companies like UPS can adapt for practical use. A recent report found that these optimizations saved UPS millions in operational costs annually. Researchers say quantum-inspired methods can solve complex logistical puzzles faster than traditional systems. Picture this: every optimized turn a delivery truck makes is a small victory in a larger battle for efficiency. As quantum technology matures, more industries will likely follow suit, transforming how we manage everything from supply chains to city traffic. Quantum computing is already reshaping medicine, particularly in the race to discover new drugs. Researchers at IBM Quantum have harnessed qubits, those tiny particles that defy classical physics, to simulate molecular interactions with precision that classical computers can't match. A recent report found that quantum simulations can reduce the time required to model complex molecules from years to mere months, dramatically speeding up the drug development pipeline. Consider how this has already helped in the fight against diseases like Alzheimer's, where quantum models have provided deeper insights into protein folding, a key factor in treatment design. This isn't just theoretical. Pharmaceutical giants are now investing heavily in quantum partnerships. As the technology matures, it's not just about faster results, but more accurate ones. And that brings us to the next frontier: how quantum computing could revolutionize personalized medicine. In 2021, a groundbreaking collaboration between Google and a leading pharmaceutical company harnessed quantum simulations to uncover potential new drug candidates for Alzheimer's disease. This experiment marked one of the first real-world applications of quantum computing in drug discovery. By modeling molecular interactions at an atomic level, the team accelerated the identification process that would have taken years using classical systems. IBM Quantum has long been at the forefront of this revolution, pushing the boundaries of hardware and software to make such feats possible. Researchers say quantum computers, with their qubits operating under quantum mechanics, can process vast datasets in ways classical systems simply cannot. Take the complexity of protein folding, something even the most powerful supercomputers struggle with. A recent report found that quantum systems could significantly reduce the time and cost of drug development. As this field matures, the implications for medicine and everyday life are profound. In the world of finance, managing risk is as much an art as it is a science. Traditional models often struggle with the sheer complexity of global markets. Enter quantum computing. Researchers at IBM Quantum have demonstrated how quantum systems can process vast financial datasets in seconds, a task that might take classical computers hours. A recent report found that quantum algorithms can simulate market fluctuations with 30% greater accuracy, especially in portfolios with thousands of interdependent assets. Take JPMorgan Chase, which has already begun testing quantum-driven risk assessments to optimize investment strategies. These systems don't just calculate, they anticipate. By modeling countless scenarios simultaneously, they reveal hidden correlations and potential pitfalls. Picture this: a portfolio manager receiving real-time insights during a market crash, allowing for swift, data-backed decisions. As quantum hardware continues to evolve, its impact on financial modeling will only deepen. But the story doesn't end with finance. This power extends further into logistics, medicine, and beyond. In 2022, JPMorgan Chase partnered with IBM to test quantum algorithms for financial portfolio optimization, achieving a dramatic reduction in processing time. What once took hours on classical systems was completed in mere minutes. This breakthrough, using IBM's quantum processors, demonstrates how quantum computing can handle complex financial models with unprecedented speed. A recent report from IBM highlights the evolution of their quantum hardware, showing how each new generation brings closer the promise of real-world impact. Consider how quantum bits, or qubits, leverage superposition and entanglement to process vast datasets simultaneously. Researchers say this capability is what allows quantum systems to outperform classical ones in specific tasks. JPMorgan's experiment isn't just a lab curiosity, it signals a shift in how industries might soon rely on quantum power. As these algorithms mature, their influence could extend far beyond finance. The next scene explores how quantum computing is reshaping drug discovery. Modern encryption, the invisible shield protecting everything from online banking to national security, faces a quantum reckoning. Current systems rely on complex math problems that even the fastest classical computers struggle to solve. But quantum computers, with their ability to process vast combinations simultaneously, could crack these codes in minutes. IBM Quantum has already demonstrated qubit systems that outperform classical counterparts in specific tasks, signaling a future where today's encryption is obsolete. Yet quantum computing isn't just a threat, it's part of the solution. Quantum key distribution, a method leveraging the principles of quantum mechanics, offers encryption that's theoretically unbreakable. If a third party tries to intercept the message, the quantum state changes, instantly alerting the sender and receiver. This isn't just theoretical. China has already launched a satellite using quantum encryption to secure communications. As quantum power grows, so does the race to future-proof our digital world. China has already begun integrating quantum technology into real-world infrastructure. A 2,000-kilometer quantum-encrypted fiber-optic network now links Beijing and Shanghai, safeguarding sensitive government communications. This system uses quantum key distribution to ensure data remains unhackable, even by future quantum computers. Researchers say this network represents a major leap in secure communications, leveraging the unique properties of quantum mechanics. A recent report found that China leads the world in quantum communication research, with over 70% of global patents in this field originating from the country. Take IBM Quantum, for example. While it focuses on quantum computing hardware, China has shifted focus to practical applications like secure networks. This shift underscores a broader trend. Quantum innovation isn't just about speed, but security. As quantum encryption spreads, it may soon protect not just state secrets, but everyday transactions. The next scene explores how this could reshape global finance. Imagine a world where data travels across the globe, untouchable by hackers or interference. That's the promise of the quantum internet. Unlike today's networks, quantum systems use quantum entanglement to transmit information. Changes in one particle instantly affect another, no matter the distance. Researchers at IBM Quantum have already demonstrated how quantum bits, or qubits, can outperform classical bits in secure data transmission. A recent report found that IBM's advancements in hardware and software have brought us closer to practical quantum networks. Take quantum key distribution, a method already being tested in China, where scientists have successfully transmitted encrypted data across 4,000 kilometers using satellites. These breakthroughs hint at a future where sensitive data, medical records, financial transactions, even national security communications could be protected by laws of physics, not just passwords. As quantum networks expand, they won't just change how we share information, they'll redefine the very nature of trust in the digital age. In the last decade, quantum computing has moved from theoretical physics labs to real-world applications. IBM Quantum, for instance, has developed systems with over 1,000 qubits, a milestone that just a few years ago seemed decades away. These qubits, tiny particles that leverage quantum properties like superposition, enable calculations that would take classical computers millennia to complete. Consider the pharmaceutical industry. Quantum simulations are already helping scientists model complex molecules with unprecedented accuracy. A recent report from IBM highlights how these tools are accelerating drug discovery, reducing development timelines by up to 30%. Meanwhile, financial institutions are using quantum algorithms to optimize portfolios and assess risk in ways that classical models can't match. This quiet shift isn't just about speed, it's about solving problems we didn't know were solvable. As the technology matures, its influence will only deepen, reshaping industries in ways we're just beginning to imagine. Quantum computing isn't just a sci-fi concept, it's already reshaping industries. IBM Quantum has led the charge, developing hardware and software that push the boundaries of what's possible. A recent report in the Journal of Supercomputing highlights how these systems are evolving rapidly, with performance metrics that outpace classical computers in specialized tasks. Consider how quantum algorithms are now being used to optimize logistics, simulate molecular structures for drug discovery, and even improve financial modeling. Researchers say the qubit, the fundamental unit of quantum information, is the key to unlocking these breakthroughs. Unlike classical bits, qubits leverage quantum states to process data in ways once thought impossible. This isn't just theoretical, real-world applications are emerging now. If you're curious to see where this technology might lead next, hit that subscribe button and follow along. And don't forget to check the description for sources that back up what you've just learned.